This video is for lessons 7.4 and 7.5. In this lesson, you should be able to write and solve multiplication and division equations. Please get your materials ready and open your textbook to page 551. Solving a multiplication equation. A multiplication equation is like an equation like 2x equals 10. Because the variable x is multiplied by 2. So we could write 2 times x, we could say 2 parentheses x, or we can simply say 2x. All of these are ways of multiplying. Multiplication and division are inverse operations, meaning they are opposites. So in order for us to solve a multiplication equation, we're going to have to undo it using division. So let's go ahead and solve 2x is equal to 10. We're going to start by writing it out. And what is attached to the x? The 2 is, with multiplication. So in order to reverse this, we need to divide by 2, and we can use a fraction bar to help us do that. So if I divide the left side of the equation by 2, we also have to divide the right side of the equation. So when we do this then, if we have 2, but then we divide by 2, we get 1, and 1 times x is x. On the right hand side, we take the 10, divide by 2, and we get 5. So we can check this by rewriting our equation. 2 times 5 is equal to 10, and that's a true statement because 2 times 5 is 10, and 10 is equal to 10. So x, in this case, is equal to 5. Let's try to solve 3x equals 6. So we'll start off with, we have 3x equals 6, and the 3 is attached to the x with multiplication. So to reverse that, we need to divide by 3. And if we divide by 3 on the left side, we have to divide by 3 on the right side. And so 3 divided by 3 is 1, and 1 times x is just x. And 6 divided by 3 is 2. So we're going to take and check our answer. We put this 2 in the box. So 3 times 2 is equal to 6. And that is true, that 3 times 2 is 6. So we replace the x with the 6, so the sentence is true. Let's try a couple. I'll do the first one, and then I'll have you do the second two. If we have 3x equals 15, the 3 is attached to the x with multiplication, so I'm going to use division on both sides to get rid of it. The 3's cancel on this side, leaving us with x, and then 15 divided by 3 is 5. We can check our answer. 3, replace the x with 5 is equal to 15, and this is a true statement because 3 times 5 is 15, and 15 equals 15. So our final answer is x was equal to 5. So let's look at B, and actually I'll do this one with you because it's a little bit different. Now the answer, the whole number, is on the left side. We still look at trying to get the variable all by itself. So what's attached to the 4, or the x is a 4 with multiplication. So 8 is equal to 4x. So I want to divide by 4 to get the x by itself. So I have to divide the left side as well. And 8 divided by 4 is 2. So 2 is equal to x. So let's check to see if that works. Is 8 equal to 4 times 2? It sure is. 8 is equal to 8. So our answer is 2 is equal to x. So why don't you go ahead and try C by yourself. Pause the recording and turn it on and see if your work matches mine. So you should divide both sides of the equation by 2 because that's what's attached to the letter x. And 2 divided by 2 is 1. 1 times x is x. And so 14 divided by 2 is 7. And we know that 2 times 7 is 14, which matches. The division property of equality. If you divide each side of the equation by the same non-zero number, the two sides remain equal. And that's what we were doing. If we take 18 and divide by 6 on the left, we get 3. If we take the 18 on the right and divide by 6, we also get 3. The same works when we're using algebra in our variables. If I have 3 times x, I can divide by 3 on the left side, and get x, and we can divide 12 by 3 and get 4. So when you solve an equation by dividing both sides of the equation by the same number, you're using the division property of equality. So let's take a look at a story problem. Vicente and some friends shared the cost of a package of blank CDs. The package cost $24, and each person contributed $6. How many people shared the cost of the CDs? So if we start off with the total package was $24, and we know that each person contributed $6. We want to know how many people contributed. So I'm going to use P for people. So what's attached to the letter P? The 6. So I'm going to divide by 6 on both sides, and we find out that 4 is equal to P. So 4 people split the cost of those CDs. Now notice my equation is written differently. They wrote 6x equals 24. That's the same thing as 6 times P on the other side of the 24, or 24 equals 6p. We still get to the same answer, 4. So let's try a story problem. In 2004, Penn Hadow and Simon Murray walked 680 miles to the South Pole. The trip took them 58 days. Suppose they traveled the same distance every day. Write and solve a multiplication equation to find out about how many miles they traveled each day. So let's do miles for our variable. So if every day they went the same distance and they traveled for 58 days, I would take the number of days times the miles that they walked to get my 680. So in order to solve this, I'm going to divide both sides of my equation by 58. And so the 58's cancel, and I'll have m is equal to, and I really can't solve this one in my head, and I know I'm just doing about, so let's just see how it lines up. We take 680 and divide by 58. I know that 58 goes into 6 0 times, but it can go once into the 68. And when I subtract, I get remainder 10, so I bring down the 0. And then 58 will only go in here one time because 50 times 2 is 100, so 58 will be larger than 100, so we need to borrow. So 10 minus 8 is 2, and then we have 5, 52. Oh, I'm sorry. Did you catch my mistake? This should be a 9, so this would be 42. Here, let's just take the time and erase it. 42. All right, well then I'm going to add a decimal. Sorry, my tools are kind of botching up on me. If I add a 0, let's find out what gets me close to 420. So 58, I'm just going to try 5 right in the middle. And 8 times 5 is 40, carry the 4, 25 plus 4 is 290, so that's too low. So I'm going to try 7. 58 times 7, and 8 times 7 is 56, carry the 5. 5 times 7 is 35, plus 5 is 400, or 40. So 406 is really close. And if I subtract, I borrow again. and I get 14, and it doesn't look like this is wrapping up. And it said about how many miles, so I'm going to be rounding to whole miles. So we have 11.7, so the 7 is big enough to push it. It's about, we can make kind of our squiggle lines, about 12 miles each day. So let's try another one. This one just involves decimals, but we're going to apply the same practice. We have 3.28x equals 19.68. And so we need to get this 3.28 off of the x. So it's attached with multiplication, so we need to use the inverse or the reverse. So we're going to divide by 3.28 on the left, and then we'll have to also divide by 3.28 on the right. And so if you do the long division, you'll find out that it goes in there 6 times evenly. And then we could check our answer by taking the 3.28 times the 6, and in fact we do get 19.68, so it's a true statement. So let's try a couple here with decimals. I have the 2 and 2500ths n equals 6.75. So I'm going to divide by 2.25 on this side and on this side. So remember, we can kind of just ignore our decimal places until later. So if we have 6.75, actually that's on 2.25, we're going to multiply by 100 to move the decimal back 2 places, and we're going to do the same over here. Put our decimal at the top. So if I rewrite it, now it's 225 divided into 675. And I'm going to take a wild guess that it's 3, because 225 goes into 6 0 times. 225 goes into 7 0 times, 67. And so let's try 3, because 2 times 3 is giving me that 6 out front. So 5 times 3 is 15, carry the 1. 3 times 2 is 6, plus 1 is 7, and 3 times 2 is 6, and I have no remainder. So n was equal to 3. Trying the next one, 1.7b equals 8.5. So I'm going to divide both sides by 1.7. The 1.7's cancel, and we're going to find that b is equal to, so let's take our 1.75, or 1.7, excuse me, divide it into the 8.5. We had to multiply by 10 to get the decimal to the back, so we'll do it on here as well. Rewrite it and solve. And 17 is about 20, so I think I'll just start with guessing with 5. So 17 times 5, 35, carry the 3, it's 85. Wow, look at that. Good guess. So 5 times 17 was 85. Subtract, and I get 0. So our answer is 5. Looking at the next one, 6.15y equals 55.35. So let's divide by 6.15. This cancels, so we have y is now equal to, so we have 55.35 divided by 6.15. We will have to swoop or multiply by 100. So our decimal goes to the end, and we'll rewrite it. 615 divided into 5,535 now. And so with 6 times what gives me close to kind of like this 50 out front. So I'm going to try 615 times, let's go 7. 5 times 7 is 35, carry the 3. 7 times 1 is 7, plus 3 more is 10. And 7 times 6 is 42, plus 1 is 43. That's a little low, so let's just try 8. 675 times 8. Oh, excuse me. That should be a 1. Oops, sorry. Something's glitching, so let me just rewrite it. Let's do 615 times 8. So we get 5 times 8 is 40, carry the 4. 8 times 1 is 8 plus 4 is 12, 48, 49. Still a little bit low. So let's try 9. 615 times 9. We get 45, carry the 4. 9 times 1 is 9 plus 4 is 13. Carry 1, and 9 times 6 is 54 plus 1 is 55. That's what we needed. So we would, we'd divide by 9. Goes in there 9 times. Looked bad, but they actually were nice numbers in the end. Well, the same thing is true then for solving division equations. So go ahead and please move ahead to page 562. So if we see an equation here like a over 4 is equal to 5, what we're talking about, remember, is that this is saying a gets divided by 4. So in order for us to break this 4 off of that a, it's attached with division, so we're going to use its inverse. Remember, multiplication and divisions are inverse operations. We're going to use multiplication to solve this. So if we take a divided by 4 is equal to 5, to break it off, we're going to multiply by 4 on both sides. So if I divide by 4, but then I make it 4 times bigger, they cancel each other out, and all we have left is a, and 5 times 4 is 20. So we can take our work, replace the a with the 20 over 4, and is that true? Is 20 divided by 4 5? It sure does, so they are the same. So a is equal to 20. So if we look at this problem, they have taken a divided by 3 equals 7. So to get rid of the division of 3, they multiply by 3 on both sides, and the 3's cancel then, leaving us with a is equal to 21. So to check that, we can take a divided by 3, we replace it with the 21. 21 divided by 3 is 7, and that is equal to 7. So the solution is a is equal to 21. So let's try some of these. Let's do 2 together, and then you can do 2 on your own. Let's do b and d together with me. So if we take and rewrite it, y over 4 equals 8. The y is attached to the 4 with division, so we're going to multiply by 4 on both sides. The 4's cancel, and all I have left is y, and 8 times 4 is 32. So we can check it. Let's replace the y with 32, divide by 4, and is that 8? Yes, 32 divided by 4 is 8, and 8 is equal to 8. So the correct answer is y equals 32. Let's do d together. I see, let's rewrite it. 30 is equal to b divided by 2. The 2 is attached to the b with division, so we're going to multiply by 2 on both sides. So 2 times 30 is 60. Divide by 2 and then multiply by 2, they cancel out, and we get b. So let's see if this is true. Is 30 equal to 60 divided by 2? In fact, it is. 60 in half, cut in half is 30, which is equal to 30. So b is equal to 60. So why don't you go ahead and try A and C on your own, pause the recording, and turn it back on when you're ready to check your work. So let's start by rewriting your equation, and the x and the 8 are going together with division, so we need to multiply by 8 on both sides. So the 8's cancel, the x remains, and 9 times 8 is 72. Down here, the m and the 5 were joined with division, so I multiply both sides by 5. The 5's cancel, we get m, and 9 times 5 is 45. So what we're seeing here is the multiplication property of equality. When you multiply each side of an equation by the same non-zero number, the two sides remain equal. And we can see that work here with numbers, as well as with algebra, as we practiced just now on the Goddets. So this is called the multiplication property of equality again. So let's try a story problem. The weight of an object on the moon is 1/6, so that's 1/6, that of its weight on Earth. If an object weighs 35 pounds on the moon, write and solve a division equation to find its weight on Earth. So the total weight is what we don't know, and we know that 35 pounds is 1/6 of it. So we're going to take the W, the total weight, divide by 6, and that gives us 35. So we'd multiply both sides of the equation by 6, and so the original weight of that object was 210 pounds. So let's try this. Nathan picked a total of 60 apples in 1/3 of an hour. Write and solve a division equation to find out how many apples Nathan could pick then in 1 whole hour. So we have to remember that it sounds like we should find 1/3 of the 60 apples. So remember that multiplying by 1/3 is the same as taking and dividing by 3. So if we take the number of apples he picks and divides by 3, we get our total of 60 apples. So we're going to take a over 3 equals 60. We're going to multiply both sides by 3 to get rid of the denominator 3. The 3's cancel and we get a is equal to 180 apples. So Carla is borrowing ribbon for costumes, and she wants to divide the ribbon into 8.5-inch pieces for 16 costumes. Write and solve a division equation to find the length of ribbon Carla should buy. So we don't know what the total amount should be, so we let that be R, and that's the total amount of ribbon, and we have to divide that into 8.5-inch lengths, and we need a grand total of 16 individual pieces. So to solve, we're going to take and multiply both sides of the equation by 8.5, and these cancel. So we have R, and 16 times 8.5 is 136. So Carla should buy 136 inches of ribbon. So let's give it a try. Allison is baking a pie, and she wants 4.5 strawberries in each serving for 8 people. Write and solve a division equation to find out how many strawberries Allison needs. So if we start here with our fraction bar, and it equals, there needs to be 4.5 strawberries in each serving for a total of 8 people. So my 8's going to go on the outside, and my 4.5 will be my denominator, and we'll let S be the total number of strawberries. Because I want to take the total, divide them into 4.5 strawberry segments, and we have to have enough for 8 people. So we're going to multiply both sides by 4.5. This side cancels, and we're left with the strawberries. And so we need to take 4.5 times 8. 8 times 5 is 40, carry the 4. And 4 times 8 is 32, plus 4 is 36. And there was 1 decimal place, so there has to be 1 decimal place. So we need to get 36 strawberries to have enough for 8 people. So at this point, You need to jump in and give it a try with division and multiplication. Find your practice assignment, and if you're struggling, make sure you come and ask some questions. And good luck.